In this recording, we're going to talk about the properties of real numbers. And there's just no way for me to cover all of the properties. So I've given you a selection here. You definitely want to read through your textbook and find others. But I wanted to give you just some of the more tricky examples of a question involving identifying what property is being used. I also want to, again, give a sense of why these properties are useful. So let's start with number 1 here. 3 plus 2x minus 5 equals 3 minus 5 plus 2x. What property was used there? Well, you might be tempted to think that it was one of these ones with 3 things being added. Obviously, this is an addition property, a property of addition, not of multiplication. Don't be fooled by that minus sign. It's still addition even if there's a minus sign. But it is in fact not the associative property, which has 3 things being added. What we want to really carefully look at is what has changed from the left side to the right side. And we can see that the 3 on the left and the 3 on the right are in the same position. They have not changed. And what's changed is this bit right here. That 2x minus 5 has become negative 5 plus 2x. And so those two were reversed. The order was reversed. That is the commutative property. The commutative property says it doesn't matter if you take the two numbers and add them, first a and then b, or first b and then a, as long as you keep the sign. So 2x plus negative 5 and negative 5 plus 2x are the same thing. So this is the commutative property. And you can see here why this property is really useful. It has to do with, well, look at this. 3 plus 2x minus 5 is a problem that we can't simplify at all because 3 plus 2x, I can't do that. I can't combine 3 and 2x. But when I switch it around and write 3 minus 5 plus 2x, now I can do that because that 3 minus 5, that part of this sentence can be simplified. I can do 3 minus 5. I just can't do plus 2x. Okay, so that's a useful use of the commutative property. Let's look at the second one, number 2 here. 72 times 2. Oh, I should say that is, we say that as the quantity, 72 times 2, the quantity times 5, equals 72 times the quantity, 2 times 5. All right, so I use the word the quantity to show when I've got a grouping symbol so that I can know that I'm grouping that bit together and then I'm multiplying the whole thing. I'm multiplying this whole thing, 72 times 2 times 5. So the whole quantity, whatever that is, times 5. All right, what property is this? I think you can see it's a multiplication property. And I've gotten a little lazy here on the left-hand side. I wrote the commutative property of addition and multiplication. I only wrote the word commutative property once, but it's actually 2 different properties. And likewise, the associative property is only 2 properties, is 2 properties, the addition version and the multiplication version. And this one is that associative property. What's changed is not the order of the numbers, 72, 2, and 5, 72, 2, and 5, but the order in which I'm multiplying them. In the first case, I'm multiplying the 72 and the 2 together first, the grouping symbols tell me. And in the second one, I'm multiplying the 2 and the 5 together first, according to the grouping symbols. So the associative property deals with the grouping symbols, how you group them together, not with the order in which they are presented to be multiplied or added. So this is the associative. And here, once again, we can see that this is useful because 72 times 2, I might be able to do that in my head. I think that's 144. But then 144 times 5, that's going to just be crazy difficult. But if I recognize that I can do 2 times 5 first, 2 times 5, of course, is 10. And then it's really easy to multiply 10 times 72. That's 720. So I can get my answer very fast if I recognize that I can do the 2 times 5 first and get the same answer as I would have if I had done the 72 times 2 first. Okay, let's look at the third one here. And I've written this out backwards. I hope this doesn't fool you. Negative 84 plus negative 28 equals negative 7 times the quantity 12 plus 4. This one is probably the most useful, most often used property of them all. This is the distributive property. The distributive property deals with multiplication and addition put together. So there isn't a separate multiplication or addition property, distributive property. It's just one. And it deals with the situation when you are multiplying by a sum. So multiplying something by a sum, I can normally, the order of operations says do the addition there in parentheses first, and so first do the addition, and then second do the multiplication because that's outside the parentheses. But the distributive property says, well, if you can't do the addition inside the parentheses, you can still multiply by that thing outside by taking whatever is being multiplied outside and multiplying it by each thing inside there. And that's what's happened here. We took this negative 7, we multiplied it times 12, got negative 84, and we multiplied it times 4 and got negative 28. And now we can add them together, and we'll get the same answer we would have got if we had done 12 plus 4 is 16, and then multiplied that times negative 7. Now, in this problem, I'm not really illustrating why this is a benefit to us. I don't know that there was a benefit in doing this. But in the next problem, I just want to real quickly demonstrate or show how the distributive property is most useful in dealing with combining like terms or adding or subtracting terms that have variables in them. So on the left we have 12n minus 5n, and you probably already know that you're allowed to add those together and you get 17n. But the distributive property tells us why we're allowed to do this. Because according to the distributive property, we could take out the n from each term and put it outside parentheses here. Because if n times 12 is 12n and n times negative 5 is negative 5n. So we can take out the n's, and then the order of operations says we can add the 12 minus 5. 12, oh, I said that wrong, didn't I? I said 17n, but it's 12 minus 5, so it's 7. And then multiply the 7 times n, and we get 7n. So because we know we can do that, then any time we see like terms, 12n minus 5n, we know that we don't have to worry about the n's. We can just take the numbers and add or subtract them. In this case, we would subtract, so it would be 7n. All right, so that, again, very useful. We didn't talk about the identity properties. The identity properties are ones where you add or multiply a number by something and it doesn't change its identity. Adding 0 for addition, adding 1 for multiplication. These are going to be really useful when we're solving equations. And then the inverse properties that say if I want to get rid of something by addition, I just add the opposite. So a plus negative a equals 0. And if I want to get rid of something by multiplication, or at least turn it into 1, I multiply it by the reciprocal. So a times 1 over a, or the reciprocal, equals 1. That's going to be really useful when we're solving equations. Well, thanks for watching. These are tricky, but if you pay attention to what has changed from left to right, you'll start to see the patterns. And I think these will be useful because you'll see as we move along in algebra that there are all kinds of ways in which these are useful. These patterns are useful in surprising ways. Thanks for watching.